Okay. Great.
Yeah, so hi everyone, welcome. This is a joint meetup between R-Ladies Gaborone and R-Ladies Dammam, which both are local chapters for R-Ladies Global, which is an organization that promotes gender diversity in the R community. R-Ladies welcome all members, regardless of what level of R you are. So even if you are very, very new to R, you're very welcome to join our community. As I said, we are recording, so if you don't feel comfortable having your image, your photo in the recording, feel free to switch it off. And we have a Google Doc that if Simi can help me to post in the chat. If you can add your name and the sign up here, this is the Google Doc. Let me show you guys. So I'm gonna stop sharing. So this is the Google Doc. I just added it to the chat, and you can write in that Google Doc, if you can write your name here, social media, where you're joining to us from, so we can get to know each other. And I have also the link to the slides. So every links for the materials, anything that you need will be added to this Google Doc for you guys. Going back here. With the Zoom, feel free to unmute yourself if you have a question. We do prefer to ask questions after the lecture. If you got also a question, you can add it to the Google Doc, and we can ask Brianna about it. If you add something to Zoom chat, I will take it and add it to the Google Doc just to make sure like everything is organized and we can follow up with all the questions. As I said, this is the chat. If you click on the chat, you can add anything. And we do really have the closed captions. So if you click in the closed caption CC, you can see all the, should be enabled. So you can see all the live transcription. I know that Zoom caption is not the best. So if you have any kind of feedback, we really care about accessibility. We want to make sure like the materials that we provide is accessible to everyone. We have a code of conduct, and what we mean by code of conduct, just be friendly to each other. You can click in the code of conduct and you can see all the code of conduct. If you did experience any kind of unacceptable behavior, please report it back to me or to Simi. We have for the R-Ladies Slack workspace where you can meet all people from around the world who part of them in the R-Ladies community. If you click on that, you can sign up to the Slack. I am part of the Arab R community, and the Arab R community is a new community to increase the visibility of the R users in the Arabic-speaking countries. So if you are from the Arab community, you want to get connected to international R community, you want to get your materials more visible, discoverable, do get in touch. The kind of support that we provide, we review any kind of abstract that you want to submit to any R conference like R Studio, Use R. We have a GitHub for the Arab R, which you can contribute through it. We add any kind of materials you have, any blog post, any R package to the Arab R website and the newsletter to provide more visibility. And if you would like to be co-organizer of any of the R-Ladies chapters in the Arab world, do get in touch. Also, if you want to present a tutorial as part of the R-Ladies or the Use R group, either in Arabic and English, please do get in touch. I believe there's Africa R, which is also a consortium of passionate African R users that support our users in the Africa to provide also improve the representation and encouraging and inspiring, empowering the African population at all genders. So if you want to get in touch, I will add the link for the Africa consortium. You get in touch with them as well. And one thing that I would like to say, this is some of the materials that we present could be a bit overwhelming for some level. So don't worry if you don't get to understand every bit. Even if you understand just one thing, even getting better, just 1% every day, that's amount up to many things over a year. So don't really stress out if you don't get to understand everything. And without further ado, I want to introduce our wonderful speakers, Brianna. Brianna is part of the infectious disease. She's an infectious disease epidemiologist based full-time in Zambia. She served as a primary epidemiological personnel for the CDC, and also hopefully I'm pronouncing that right. She's funded by the President Emergency Plan for the AIDS Level HIV Treatment Organization, where they provide services or programs that support data collection, databases, design, and analysis. She also assisted globally through programs in the affiliated Center for International Health Education and Biosecurity at the University of Maryland, Baltimore, supporting 8 countries across the Sub-Saharan Africa. She applies quantitative data analysis to inform epidemiological investigations and practical research in infectious disease prevention and treatment in real-world setting. She's published extensively in burden of disease estimation using various study design and has expertise in qualitative methods, as well as analysis of high throughput and advanced molecular detection techniques. She has planned and organized a number of global health data workshops in Africa, Asia, and the US. So do join me in welcoming Brianna. The floor is yours, Brianna. I'm going to stop sharing now.
Great. Thank you so much, Batul. You can hear me okay?
Yeah, perfect.
Great. I'm just going to go ahead and share my screen. So let's see. What are you seeing? Are you seeing?
I see in both screen, like for the presentation, but if you can enlarge that one, it'd be
great.
Good.
Perfect. Okay. Yeah, so I just want to make sure you were seeing the correct screen.
Yeah, we see it
now. You see the presentation. Okay, great. So good morning, everyone. Thanks for joining. Really happy to be able to present. I have joined R-Ladies in the past. I'm actually originally from the East Coast of the United States, from Philadelphia. So I've originally joined R-Ladies through Philadelphia. And now that I'm in Lusaka, I'm kind of hoping to shore up some support for R and R use here in Zambia. So if you are joining us from Zambia, welcome, and please reach out to me and let me know if you're interested in kind of developing any further collaboration or perhaps opening an R-Ladies chapter in Zambia. I think that would be great. My presentation is really, so I'm going to just talk about a little bit about who I am and how I've gotten to this point in my career. So I would say I'm kind of like a mid-career at this point. I graduated with my PhD almost 10 years ago now, 8 years ago. So it goes very fast. And I've had a number of different positions and I haven't really followed a traditional kind of academic path. So I think I've touched a couple different, both public and private sector. So I think my kind of career path is a little bit unique, so I can give some insight on that. And then I'll just talk a little bit about how I use R in my current work, as well as some of the past experiences that I've had using R. And then I'll kind of promote why I use R instead of Excel. I will say that I do still use Excel and I think it's still a really useful tool, but I do find myself sometimes when I use it too frequently, I do find myself kind of wishing that I had, or forcing myself to switch over to R, because I know that in the long run, it will actually be better for me if I code it in R. So I'll talk a little bit more about that. And then I'm going to walk through 3 examples. And these 3 examples are just, I tried to keep them as straightforward as possible. They're related to the work that I do right now. And the first one is just a really quick, easy way to group aggregate data that we currently receive from a number of our health facilities in Zambia. And then the second is what I call just a pre-post analysis. So just a quick analysis of an intervention that we administered, I believe 6 months ago now, with the launch of the antibiotic guidelines at a teaching hospital here in Lusaka. And then the third example that I'll walk through very kind of briefly just to touch on is power analysis, which is a kind of high demand activity that epidemiologists and statisticians are kind of very frequently asked to provide input on, and it's something that I always am asked to do for grant applications and things like that. So I just wanted to touch on it briefly because I wanted to show how actually easy it is in R to do. I won't get into details about like, I'm going to try and stay away from really talking a lot about, you know, the epidemiology as a methodology. But I'll try and marry in kind of the epi concepts that I use every day with the R work that I do, because epidemiology as a field itself is quite large, and you know, this is not an epidemiology lecture, but more about how I use R as an epidemiologist. So just getting in, I'll talk a little bit more about that as well. Well, I will talk about what epi is for those of you that don't have a background. So just to talk about my career path. So I got my bachelor's degree from a small liberal arts college in Pennsylvania called Ursinus, and I got my bachelor's degree in biology. I think at that point I was thinking I maybe wanted to go to med school, or I wasn't very sure. So then after I graduated, I moved and I started working on a cohort study, which is one of the primary study design, observational study design types in epidemiology. And I started working in a cohort study of juvenile diabetes patients in Colorado. And my role in that study was really to do the data collection. So I was meeting with parents, I was meeting with children, taking clinical samples, taking clinical measurements, talking to them about administering all sorts of questionnaires. So basically I was on the data collecting side of the study. And then I actually, so I had some exposure there to public health in that aspect, because I was involved in this large cohort study and I thought it was really cool and had potentially many opportunities. So then I actually took a course there in immunology. I decided that I wasn't going to go into the lab sciences, but that I wanted to go back to Pennsylvania and get my master's degree in public health. So I moved back to the East Coast, and then I got my master's degree in public health from Drexel University. And while I was there, so for about 2 years, I worked on a study. My thesis study was evaluating the impact of a program, a WHO kind of recommended program on neonatal resuscitation in Malawi. So I didn't actually get to travel to Malawi, unfortunately, but it was a very interesting data set. So, and that actually was, the design of that study was similar to the pre-post analysis that I'll be showing you later on as an example. And that's really what you would call a quasi-experimental analysis, or pre-post is also used. It's not really kind of a standard rigorous observational study design, but it's used pretty frequently when kind of interventions are rolled out and you want to assess how people are doing prior to and then after the intervention is implemented. So after I got my master's, well, actually during my master's, I also worked, I had an internship at a pharmaceutical company called Merck. Philadelphia has a large number of pharmaceutical companies in the area. And I was lucky enough to have an internship and then be hired as a contract employee there. And while I was there, I worked on a SQL database, building a database of healthcare quality measures. So I got some exposure to more coding there. And then after I was there for about a year, I decided to apply for my PhD. And then that's what led me to University of Maryland, Baltimore, where I did my PhD work in molecular epidemiology, which if you know epidemiology, so it's the study of the distribution and the determinants of health within populations. Molecular epidemiology basically just means that I'm using molecular methods to measure those either exposures or outcomes or different variables of interest. So the molecular component really just talks about how I'm actually measuring things. And in my case, I was involved in a large case control study. It was called GEMS. And it was on assessing the burden of diarrheal disease in a number of different countries across Africa and Asia. So my study for my PhD was actually kind of a smaller sub-study of that using quantitative PCR to measure specifically Shigella, which is a pathogen that causes diarrheal disease. And that work has really, while I've moved on from it, it actually has kind of, the burden of Shigella disease has been kind of more recognized and since the GEM study, and a lot has been learned about it since then. So that's really great. I've also worked during that PhD, I also did have a paper on microbiome data. And so I was incorporating the microbiome data with the clinical data. And so I think this is a common theme I see as a molecular epidemiologist, trying to integrate basically molecular or genomics data with clinical data or even study design type data is definitely a challenge. So standing at that intersection is, and having people that know how to kind of merge those two is really important. So I feel lucky to be involved in that. And I actually do serve, I currently do serve as associate editor for the Microbiome Journal. However, I don't really, I review papers, send them out a couple of times a year. But if anyone has questions about that kind of process, I'd be happy to talk about it as well, because it has been like a really great learning experience. So after I graduated my PhD, then I went back to Merck to pay off my student loans, basically. And so I went back to industry. And while I was there, I worked in what's called outcomes research. And outcomes research is basically using what you would call kind of phase 4 studies. And it's essentially to do research after a drug or a vaccine has entered the market, or it's not necessarily like a clinical trial. So you're applying basically the types of studies that I did were things like assessing adherence to a medication, assessing uptake of a vaccine, establishing the burden of disease for providing kind of the use case for certain vaccines. And so I worked on a large number of projects there. I would say a lot of the work that we did at Merck, it was, I would be the lead, and then we would be contracting these studies out to different organizations. And then so I would organize the protocol across multiple organizations and try and execute and really work on the statistical analysis plan and things like that. I will say at Merck, is probably where I used R the least. And I'll talk a little bit more about that, about why that is. And then after Merck, I moved to Penn, where I worked for 3 years on a Gates funded project. It was really focused primarily on data science. It still exists. It's called ClinEpiDB. I really encourage you to go and check out that website. So what it is the Gates Foundation saw, an unmet need of the storage and the retention of a lot of their data and the availability of a lot of the data from the studies that they were conducting. So they had contracted with us to actually start building essentially what is similar to a repository, but it's more a data exploration tool for the studies that the Gates Foundation supports in maternal newborn child health, in malaria. And so basically the data that you can find on ClinEpiDB are studies that have been conducted by Gates Foundation supported grants that generally are very large. But the cool thing about the platform, which we rolled out, I think we launched a year after I began working there. If you visit the platform, you can click through, and it's basically a user interface that allows you to query very large epidemiologic data sets. And now in the past few months, they've actually launched a new kind of beta version of their site where they have really improved the visualizations and allow you to do a lot of really cool things with the data that's on there. So I would be happy to talk about that further with anyone or direct anyone to contacts there. It's a really great resource. And if you're looking for data, a lot of the data sets on that resource are open, so you can download them and use them. You could use them in lectures, you could use them for your own research. And then there are some that are closed, but if you submit a request, you can then get access. And so throughout this whole time period, you know, obviously at Merck, I was funded through, you know, private entity. But so leaving Penn, then I decided that I would want to, I wanted to really kind of apply my epidemiology skills in a real world setting. And so that is when I am currently now employed again by the University of Maryland, Baltimore. I call myself like a full-fledged epidemiologist at this point. And I am kind of boots on the ground in Lusaka and helping with the HIV and HIV prevention and treatment programs that we are contracted with the CDC and collaborate with the Ministry of Health here to provide HIV testing services, ART services, and a number of other programs. And I also have some funding from NIH on other grants. So just kind of a large array of things. So I've been funded through both, you know, the Gates Foundation actually did fund a lot of my PhD work. PEPFAR and CDC is what funds my current work, for the majority of my current work, as well as NIH, a small amount. So I've been funded by, and the Gates Foundation definitely has kind of a different funding stream than some of these other organizations. So I could talk more about that if anyone's interested. But primarily now my funding is through, you know, the US kind of public sector. All right, so that is my long career path. So I've done a number of different things and haven't really followed the kind of traditional like PhD, postdoc, you know, associate professor. At this point, I'm considered staff at University of Maryland, Baltimore. I'm really happy with where I am. Working as, you know, a staff member providing epidemiology support. So we'll see where that goes. And so I did just want to put out this disclaimer that, you know, this presentation is really prepared in my own personal capacity. The opinions that I express are my own. They don't reflect the view of any of my current or previous employers or funders. I will also put out the disclaimer that, you know, while I've been using R for a really long time, I wouldn't call myself an expert R user. I think I've gone through kind of ebbs and flows with how often I use it, which I think many of us do. And I'm at this point in my career right now where I am using it almost every day, if not every other day. And I'm really enjoying it. So I'm happy to be giving this presentation, but I will say that, you know, I don't write my own functions very often. I think I was more proficient maybe when I was doing my PhD, but I'm still learning every day. And so the things that I'm showing you are not necessarily the only way or the best way to do anything, but I think seeing how other people do things and kind of spurring that, you know, seeing how other people approach things is really important. So just to say that I don't necessarily say that whatever approach that I take is necessarily the best approach. You may find that something works better for you, and that's great. But any input or advice, I'm sure I'm welcome to receive as well. So again, just to kind of go back to original kind of question here, you know, like what is an epidemiologist? And this 4th edition of this modern epidemiology book just came out. I actually trained using the 3rd edition. And it really is kind of like the Bible for you know, epidemiologists, or, you know, it's really the go-to reference guide for people who are interested in epidemiology or who apply epidemiology in their daily kind of career. It does tend to get a little bit more advanced. So like if you're interested in learning some kind of more, it's beyond an introductory text basically. And so basically similar to what Batul and Simi have pointed out, that it really is, there's different kind of standard definitions, but really we're looking at the distribution and the determinants of health-related states or events in specific populations. And this is really key, the word population. So when you think of like clinical health or clinical, like a doctor, they really are worried most with the health of an individual, and they're generally dealing with an individual one-on-one, whereas an epidemiologist is really looking at the health of a population as on a whole. And we're generally kind of looking at defined populations, defined exposures and outcomes, and then how we can apply this study to control health problems. So really kind of the public health approach then to epidemiology. And so it's a really broad field. I will say you can apply it in many, many ways. There are veterinary epidemiologists. There are epidemiologists like me who are more familiar with kind of like the genomic side. There are epidemiologists who do kind of like social, qualitative epi work. And it really can be applied in it's more of a methodology that can be applied in a variety of different scenarios. And I know we've kind of risen to fame with the coronavirus epidemic. You know, I think really witnessing this epidemic in our kind of time right now is something that will be studied for years and years and years to come in the epi community. And there's just so many aspects of it that really could be investigated and reflected upon, and so many learnings from that I think, you know, we will be learning from it forever. So just to go on, then I just talked a little bit about, you know, what types of studies I've been involved in the past. I'll get into kind of some more specifics, but in general, I'm looking at, you know, the health states of populations and how we measure that. And so how do I use and have I used R? So I'll talk about the specifics, but so really, I actually used SAS. So every kind of university I've found has a kind of statistical software of choice, right? And primarily because they probably have a license for that one software and they don't want to have to license every software. And these, you know, SAS and Stata are pretty, I would say, prohibitively expensive. And so I really learned, University of Maryland, Baltimore, focused on SAS. We did have exposure to other statistical softwares, but we did not, we focused primarily on SAS, as that was the one that the license was available to us, sorry. And so really I became kind of most proficient in SAS when I first started my PhD. When I started looking into more of the genomics data, that's really when I started to get into R. I really just found that using R was easier than using SAS for these like super large data sets. The types of like kind of custom things that I was doing with the data sets were much easier to apply in R. So I kind of bounced back and forth between both SAS and R during my PhD. And I actually learned R prior to RStudio, and RStudio was like a life-changing experience. And it really is what kind of brought me back into using R because it is such a great, like kind of, it incorporates the point and click interface that I think everyone is comfortable with, but then you can still have like the coding portion as well, right? So RStudio, great tool. I don't know of many people now that are first learning R that don't use RStudio. I know that many people use R at kind of command line, but RStudio is definitely, if you're learning, it's kind of the #1 tool. And then I just picked out a couple of the hex stickers from the packages that I probably use most frequently and that are most helpful to me. Tidyverse, obviously, I think anyone in the R community knows that this is a huge kind of development for the R community and just data analysis in general. I think the approach that the Tidyverse takes and the kind of streamlining of how you really look at data and the structure of data is something that I'm constantly trying to kind of spread awareness of with my colleagues and with people that I'm mentoring, and trying to kind of show them, like, how do I structure a data set? How do I interrogate a data set? And the Tidyverse really helps to kind of implement those activities and all in one big package, right? So it's kind of a go-to. I always have it loaded in my libraries. And I would recommend it for anyone that's also just getting into R. Ggplot as well, which is a part of the tidyverse package, is a lot of times, so I really like to play around with Ggplot to make pretty figures and diagrams. I do revert to Excel every now and then if I just feel like Ggplot is over engineering. But I will say I love Ggplot. It makes beautiful graphics. I'm constantly, it's kind of funny because you'll see, like, even in media today, particularly with the coronavirus epidemic, you'll see, global publications and news sources, and you can tell that they maybe have used Ggplot in their analysis, just because you can tell by the style and like kind of what the graphic looks like. So I think that's kind of cool. Reader, I think, obviously, so a lot of our data sets come in, at least now, from other data collection software. So I'm getting the data either as an Excel document or as a CSV. And so really, like, Reader, reading the data into R is kind of key. And then Lubridate is, so I hadn't really worked with longitudinal data very much previously, because my prior work has really been more about case control study rather than cohorts. But I've recently, I recently have been using, analyzing more longitudinal data, and it is very, very complex. As anyone knows who's tried to look at, day, month, year, month, day, year, everyone has a different format for dates. They're very hard to compare. They're difficult even to import sometimes. So Lubridate is a really super useful package that I use to really clear up any of those issues with dates. And I didn't include that in the analysis, the pre-post analysis that I shared, just because I felt like it could be its own complete, 90-minute session. But I will say that I have used it, and if anyone wants to see some of that code, I'd be happy to share it. And then finally, I think, when I was working at Penn on the ClinEpiDB platform, we primarily used R for data processing at that point. And so what we would do is we would take data sets that we had received from investigators. One of my colleagues, Danica, shout out to her, she wrote some really great scripts that we used to then run the data actually through some processing packages. And then we would, because our goal was really to interpret the data that investigators were giving us and then display it in a way that was meaningful to other people. These packages really allowed us to kind of investigate the data that was, and provide kind of what you would call metadata, or, kind of the important data about the data. And so R really helped us to do that. So it was a standard kind of part of our processing pipeline for ClinEpiDB. And I would encourage you, if you're interested in that, to go ahead and visit their website. It's clinepidb.org. Explore some of their tools and their pipeline if you're interested in data sharing or anything around kind of data repositories or things like that. It's a really great resource. And then while I was there, I really did learn more about, because it was a website and we were doing database releases, I really learned a lot more about version control, started using GitHub a lot more, and really kind of learned more. And again, GitHub and R, the interface between the two it's an entire lecture on its own, but I will say I don't use GitHub as much anymore because I'm not sharing my code very frequently, which I probably should be doing. But I kind of work in a silo right now with R, but I will say that it was an invaluable resource when I worked collaboratively with a large group. All right. So I think that's probably enough about like my background, and we're already 35 minutes in. So I'd like to start just to talk about some of the examples of how I've used R. and walk through the 3 that I've provided. So on the GitHub repository, which I believe that Batul and Simi have shared in the chats, you'll see that there is an R project, R code, and 2 CSV data sets that you're welcome to download and kind of work through with me. I'm just going to go through a couple slides of introduction just so you kind of know what the data sets are about. And then I'll move over to actually showing you working through the code, you know, as we go through. Batul, is everything okay? Do we have any issues, or should I just keep going?
Yeah, you can keep going. It's fine. I've shared the materials link in the chat. Thank you.
Great,
Brianna.
perfect. Okay, so grouping aggregate data. So this is like a super helpful thing that I think a lot of my colleagues here in Zambia could really benefit from. We primarily use Excel for a lot of our data, you know, our data storage, our data management. I mean, we do use databases, but the people who are actually kind of looking at and reporting a lot of our indicators are using Excel to kind of interrogate some of the data and store it. And there's a lot of filtering and a lot of sorting and counting going on, and kind of custom equations being written. And so this is a real example of like how just a few simple lines of code in R can really make the process of analyzing this data much more efficient. And so, and the other thing I think that was really new to me with my position here in Zambia, so previously, all of the data that I had investigated was generally in the unit of analysis. So basically, like what one row of data meant was generally corresponded to one person, right? So every person would have one row of data, or more than one row of data if they had more than one visit, for example. Or it would be like the number of households. So each household would have a row of data. And when I came here to Zambia and I was working in more of kind of a public health program, that type of like what we call client level data was not necessarily available. And I think for large, you know, kind of disease monitoring situations, you might not always have the data about every individual case available to you. So what would happen is, so what happens here locally basically is that every health facility or every kind of health post will collect data and then report up to the district level health facility, which then reports up to the provincial, which then reports up to, you know, so basically the most discrete unit of measurement that you have is at the facility level. So each facility is reporting, you know, the number of cases of the disease they have, the number of people treated with the disease, the number of people eligible for the disease. So what I have here is basically just a line list of the typical type of data that we might get from health facilities. So there's, I think, over 3,000 rows in this data set. And what you'll see is that the variables are basically what period was the data collected in. So this is a mock data set. I just made up all of the components, but there are very similar. So basically, like I use city instead of health facility. Age group are the typical standard age group groupings that we use from the HIV PEPFAR kind of perspective. We also group individuals sometimes by gender or by, you know, just type of person or something like that. There's generally another sort of grouping variable. Here I used career. So I just kind of split up astronaut, surgeon, pilot, farmer, and epidemiologist. And then you'll see here, so like in the city of Baltimore, in September of 2021, astronauts aged 15 to 19 years, there were 10 of them surveyed, one tested negative. So this data over here is actually like the count of the individuals who met, you know, survey, tested positive, tested negative, treated, untreated. So you'll see like there's a large number of combinations of this. So that's why you have so many rows, right? So you have the Baltimore surgeons in this time period, the Baltimore pilots in this time period. And so there's a lot of different kind of groupings that you can look at within this data. And generally, so like CDC might ask us, you know, like how many astronauts under the age of 25 tested positive, right? And they may want to know that information really quickly. And so what we'll do generally, my team will generally just look at the CSV doc or kind of explore the database and count manually. But really with the use of R, you can actually do this very quickly and very reproducibly, which is another huge benefit of R, is that having your code, running it and having it produce the same result every time is a huge benefit. And so the package that I use for this is called Summary Tools. It has a number of different features that are really useful for epidemiologists and data scientists. The one I'll use today is called Summarize. And so basically what I would do is, you know, I get basically the CSV data, load it into R where it looks like this now. And then my output is essentially a table where I have the different kind of age or whatever I want, whatever group I want, organized by the count of different mechanisms. And then I can also kind of compute some metrics. So that's what we'll be doing in the first kind of use case that I have, is basically taking this lineless data of, you know, over 3,000 city, age, career, period combinations, and really summarizing that data in a nice kind of quick and easy way and flexible and reproducible. So I'll walk through that. And so that is the aggregate data CSV and the aggregate cases R file. Just one second, let me. So, and so that actually, just to say something about this, so this is really just disease surveillance, right? There's no like study design necessarily here. Really, this is just monitoring the prevalence or the incidence of disease within a population, which is really a critical component of what epidemiologists do. So, you know, for coronavirus, for example, like, so I didn't specify what disease we were looking at here, but you could imagine that like every health department or every health facility or every district health office is reporting these numbers. And so you want to be able to summarize and look at them by different levels and report them in very easy ways. So I think this is really how that disease surveillance data could be captured. It is captured, at least for HIV here in Zambia, and is very kind of amenable to our exploration. All right, so moving on to my next analysis. So the pre-post analysis, so what happened was we actually had a global health fellow here with us who one of the activities that she was involved in was rolling out the antibiotic prescribing guidelines for the teaching hospital that we work most closely with. And so this was just a kind of a set of guidelines. So that's what this is. It was both printed out and then also on an app. So this is a screenshot of the app. And you can see there's just information about, you know, different clinical syndromes. And then here's the like kind of table of contents text. So what happened was she administered a survey prior to rolling out this information and collected just information, you know, basic demographic information, their training status, what their subspecialty was, and then a number of questions. There were actually 15 questions about that particular person's maybe antibiotic prescribing preferences, or just questions about, you know, in this scenario, what antibiotic should you prescribe? So she did this survey prior to rolling out the app. She launched the app, and then she did a follow-up, the exact same survey with the exact same questions a few months later. And so the goal then was to see, did the rollout of this app or these guidelines actually improve the scores on the antibiotic questions that she had put together. So it's basically kind of testing the efficacy or testing how effective was this intervention, which was the antibiotic guidelines. How effective was that in increasing the knowledge of the individuals that would potentially be using it? And so that's what we would call kind of a pre-post analysis, where you collect data prior to administering an intervention, administer the intervention, and then look at data afterwards. And you would compare the two. And generally it's within the same populations. There are lots of limitations about, you know, how you do this and roll it out and nuances. But for the purposes of this, just to keep it very simple, the data set that I deposited, I randomized some of the responses. There were only 60 responses. And one of the big kind of data cleaning learnings from this was actually merging, like, how do we identify people that took the first survey and match them with the same people that took the second survey? And so we use their telephone numbers as their unique identifiers, but then, like, you know, what if they tried to take it more than once, or they only took the post and not the pre? So that was like a big part of the data cleaning. But the point at which I've given you the actual data file, it only has individuals that had either the pre or the post, and the data for each individual is contained within one row of data. So you have both the pre and the post data within one row in the data table. And so really what I've used primarily in this analysis is all the tidyverse packages. And then finally, power analysis, which is kind of the crux of grant applications for anyone that's doing academic research. Really any research in general. So for clinical trials, for those of you that don't know, a power analysis is basically you come up with a hypothesis, you know, is drug A more effective than drug B? And then you want to know that you have either surveyed or enrolled enough participants in your research study to actually be able to prove or statistically test that there is a difference between those two populations. So it's a way to ensure that you're enrolling enough individuals in your study to actually test the statistics that you want to be able to test. And there are lots of nuances, and I'm not going to get into details, like, you know, I could start writing out equations, but basically this is kind of, these two tables are kind of what you would see in a grant. So what someone that was evaluating a grant would want is to see that you've estimated, you know, you've very clearly specified your hypothesis. In this case, this is a case control study. So we want to know whether or not the exposure occurred more in cases versus controls. So what we do is we look at, so N equals the number of individuals. This is the proportion of exposed cases, proportion of exposed controls. The odds ratio, which is a statistical measure of association. Basically higher means more, a greater effect size. Alpha, which is 0.05, which is kind of a standard discriminatory level in power calculations. And then your power, which here it's all 100%. Because we're lucky to have kind of a large sample size, but many times you would actually run this analysis in different ways. So what you do is you actually run the power analysis and you modify certain things every time you run it. So each row of this table is one power calculation. And so you'll notice that the difference between this row and this row is that the number of exposed controls increased, which corresponds with the odds ratio. And so the question is when I only have 10% exposed controls and 50% exposed cases, then how many do I need to achieve 100% power? And you'll see that it's actually the same number as a difference between 50% and 5%. And in this case, 225 is our sample size for cases and controls, whether or not it is in any range of this exposed proportion or exposed control proportion. And so you'll see how you can do that with basically varying these different components within the R package. And so the R package that I have used in the past is called PWR, which presumably stands for power. There are a couple other packages as well. There's one called Epi-R, which actually is really useful for a number of other reasons as well, but they also have a power analysis portion, and that one is also very nice to use. And I do provide, in my code, I did provide one example of that. So I think in the code that I shared, there's essentially two examples. One where you have binary outcomes or exposures, so where there's either exposed or not exposed, or a case or not a case. And then one where you're actually measuring a mean. So you're looking at the difference between mean phenotypic susceptibility, so which is measured basically just on a continuous scale. So you have what's the difference between 35 and 25. So this is just you know, a mean of 35 versus a mean of 25. And so those are kind of the two base cases for maybe a power analysis, where you're looking at either binary exposure or outcome, or a continuous measure like a mean. So finally, before I get into going through the code, here are just some resources. The Epidemiologist R handbook is fabulous, super great resource, totally recommend it. It's developed by this, I think called Recon, this team called Recon. And it's really useful for both learning and applying epidemiology skills. So highly recommended. I use it probably every other week just to kind of use it as a reference. So that's really great. It totally talks about how to use R from an epidemiologist perspective. R-Ladies Sydney also, if you're learning, has a really, really great course called Basic Basics. And I've actually used some of their slides to teach some R concepts. And it's all on their website and open source, and it's a really good tutorial walkthrough. This refomonas.org general R, this is another kind of teaching tool. It's basically an open source course on how to get started with R, and a reference guide. This link, mutate and if else. So mutate and if else statements are two kind of tools that I use on a very, very regular basis when I'm kind of cleaning or transforming my data. I do use them in the one example, our pre-post example. And I'm constantly like forgetting how to do something, and I actually have this bookmarked, and it just reminds me in very simple terms how to use mutate and if else, and it's super helpful. So I thought I'd share that. The CDC has a managing data workbook that actually provides some really good guidelines about how to manage disease surveillance data, or just data in general. So kind of best practices there. And then this Recon Learn, this is also a resource it's focused on outbreak response, health emergencies, and humanitarian crises. So basically how to use R within those scenarios. Okay, so that's it for my slides. And let's go to the good part, which is the R. How do I, what tool or Simi, how do I increase the font size? Do you know? Oh, here we go, Zoom. Oops, that's the wrong way.
Well, the way I do it, usually I go from preferences, and okay, that's also does. Okay, that's good.
So is that big enough, or should I do one? Well, there's one more. Is that good?
Yeah, that's very good. Would you mind me asking a couple of questions?
Yeah, no, go ahead.
Okay, so we have one question about someone asking about a link to the gate-funded repository that you mentioned. I copied one once I found it in Google. I googled it, but I'm not sure if it's the one that you were trying to mention. Is that the one?
Yeah, let me just.
Okay.
No. That's
okay.
Just here. I'll show you. I'll actually bring it up so you guys can see. It's a super great resource. So basically, this is the platform, and again, they just launched this new site, which is really spectacular. So each one of these cards that you see here is basically a different study. So this is a malaria study. This GEM study is the one that I worked on for my PhD. And so basically, if you click on any of these, it actually takes you to the data that is available. It does take a little bit of time sometimes, but it's super useful. And then if you just go to the summaries table, it might be slow because of my Zoom, but anyway, so yeah, so these are all generally Gates funded studies, but there are some other ones as well. NIH also has sponsored a number of the malaria studies that we have contained in there. But yeah, so if you have any further questions about that, do feel free to reach out to me. I can connect you to that team very easily. So you can see this is all the data sets that they have currently. So there's about 30 of them loaded right now, from schistosomiasis to diarrheal disease to malaria. So if you have interest, it's a great resource. You're on mute, Batul.
Okay, I was just saying that's very, very cool. I didn't know about it. And we have also a second question about exploratory data analysis. Someone is asking, is there a reason why you're using summary tools over other competitors like BizData or Data Explorer, etc.?
No,
so why
not
do you
really.
like it? Yeah.
Yeah, I don't know. I feel like for some reason I always just kind of go back to it. I've also used it if I do R Markdown. It also has some really nice like renderings when you do R Markdown. So that's another kind of reason why I like it. I don't know. I just kind of have taken to it, I guess.
I totally agree with it. It has really nice rendering when you do R Markdown. So I would also use it. Yeah. And that's the only question that we have. You can go to the practical.
Okay, cool. So you'll see here I have like my project loaded. So these are my R scripts here. And then, so the first one I'll work through is just this aggregate case one. And again, like the way that I write my code is just, I don't know, if I come at it from like a statistician or epidemiologist perspective. So I'm not like a computer scientist. So I can't speak to, you know, whether or not this is really kind of the best way. I do try and annotate and document as much as possible. But, you know, sometimes that escapes me. And then of course I go back to it later and I'm kicking myself for not doing that. So, but generally, you know, this is the format that I take with all of my R code. I do use R Markdown sometimes if I know that I'm going to be sharing my analysis with others. I'm still kind of learning it, to be honest. I love the way it renders and creates like an HTML, and that I can send to other individuals, because a lot of my work is like actually explaining my analysis to other people. So creating an HTML file that really walks through the steps of the data analysis is really super helpful. But if I'm just doing something where I know I'm just going to be kind of giving generating a report and sending it off as like, you know, either PowerPoint slides or an Excel table, I generally will just use a regular R script. So I've already loaded my libraries. So in this, I'll use here. So I have been using that, the here package to load my CSVs. Reader, obviously, Janitor, which is a super great package. I'm sure you guys may have touched on it in a previous R-Ladies. It's really used for kind of just making your data a little bit more clean, which I constantly get extremely dirty data with very confusing column headers and things like that. So I always like to load that. And then summary tools and tidyverse are the two kind of components where I'm using. So I'm gonna just go ahead and, so, you know, I'm gonna call this data set aggregate. And I'm not gonna lie, I also am not ashamed to admit that I very often also sometimes, if I know that I have a data set that has like a lot of dates in it or something like that, I will use the import data set button and go to Reader and import that way. What I will generally do if I do it that way is that I will import and then copy the code and save it in my script, so that I only really use the import text user interface tool one time. And then moving forward, I'll use the actual script. But it is super helpful, you know, like if you're comfortable using a user interface, like use those tools, you know, if it works for you, that's, you know, all more power to you. Like, I think just use whatever works. So basically, because this is a pretty straightforward data set that really just contains kind of like, you know, some continuous and some binary and some factor data, I just am going to load it using the here. And so if I load it here, and you can see here, there's 3,840 observations and 9 variables. So if I open it up, you can see this looks exactly like the version that I had presented on the PowerPoint slides. Hold on, I'm going to make this a little bit bigger. There we go. And so we have our period, the city, age, career, number of people surveyed, the number that have tested positive, the number that have tested negative, the number that are treatment eligible, and then the number that are on treatment. And so generally after I load in a data set like this, I of course want to know like some questions about it. Well, actually, so first I tidy it. So it's already pretty clean. You'll note that there is like spaces in here. It is actually, because I made this, is actually abnormally clean. Normally, if I get a file from like an output from a database, it will actually have some pretty wacky variable names. So what I always like to do is use the clean names package in Janitor just to clean it up. And then you can see now, you know, there's an underscore instead of a space, and it will change all of these to lowercase and just make it much more easy to reference the variables. So I do use that a lot. Then I also, many times I think when we're collecting data or, you know, reporting surveillance data, there may be many blank rows or columns, like data that sometimes is just in there because it's like an artifact of the database or something like that. So I do like to remove empty rows or columns. In this case, there aren't any, but I do like to traditionally use that. And then, you know, I like to just do a little bit of data exploration. And so here I'm using the freak command. And so when I run that on period name, you can see down here that basically the timing of my data is from December 2020 to September 2021. And you'll notice that there are 320 observations for every period. And that's just because when we get the data from the database, we get one row for every potential, basically, combination of aggregate. So we'll get a row of output, whether or not there's data in it or not. And so there'll always be like the option of having a row. There are like sometimes in our data, when we download it from our collection platform, you can remove blank rows. But generally I like to keep them all and just kind of explore that way. So here you'll also notice that for city, these are all United States cities, places that I've lived, places, oh, actually, no, there's London and Tokyo. I actually chose places where there are world marathon majors because I like to, I'm a running enthusiast. Plus Baltimore, where I've lived before. And you'll see again that there are these, let's see, 1, 2, 3, 4, 5, 6, 7, 8 cities, and then 480 of each. And then for age groups, you can see here 15 to 19, 20 to 24, and so on. And there's no missings. And then for career, again, the same number of everyone: astronaut, epidemiologist, farmer, pilot, surgeon. And so like on the ground level, this is not that interesting, right? Because you know basically that like there's no difference between the number of astronauts and epidemiologists in this data set. So like what's going on with it? You know what I mean? Like why is that interesting then? So what I'm going to do, I'm going to use you know, a tidyverse option to filter the data set. So say I only want to look at epidemiologists maybe are too like intense on their disease surveillance. So you don't want to look at the cases that were reported by epidemiologists. You only want to look at cases that were reported by astronauts, farmers, pilots, or surgeons. So in order to actually filter just to those, and again, there's another way to do this. You could actually do the inverse where you remove the epidemiologists. Whatever approach you take is totally fine. That approach probably is more efficient. but it's just not the one I thought of, I guess, at the time. But so if I run that line of code, you'll see that now the number of observations in our data set has reduced to 3,072. And then finally, so this is really where kind of the meat of the tool comes in, or the analysis, this like very quick analysis that we're doing. So what I want to know is, you know, like how many people, so what are the totals overall? How many number of people were surveyed? How many tested positive? How many tested negative? How many were eligible for treatment? And then how many were treated? And then I also generally like to compute a couple statistics on the different groups. So here I've calculated the treatment proportion, which means it's the sum of the number treated over the sum that tested positive. So basically, out of the people who tested positive, what proportion of those were treated? And then I also want to look at treatment uptake. And so I'm looking at basically the number of people treated over the number of people eligible. So we want to know, like, of the number of people eligible, how many people are being treated. And so like this type of analysis, like for example, like vaccination, you could use it to look at vaccination data, anything like that. And so what I generally do at first is just do, you'll notice that this is dplyr, and then I use sum as my kind of function to compute the survey, the total amount. And you can use different, different commands here. So you can use, like, depending on what you want to do. Sometimes you want the mean, sometimes you want to perform like a addition or subtraction. You'll notice here I'm doing a division and then multiplying by 100 to get the proportion. So this command actually, it uses the summarize from dplyr, and then it also uses mutate again, which is how I generally create variables very frequently. So this again also is from the tidyverse package. And so, and I also, you know, when I first learned R, I didn't even use this, the caret bracket thing. I just started using it in the past couple of years. It's really been much easier. I used to just type out everything. So I'm just going to go ahead and run it and see what we get. So you'll see now this produces a data set over here. If I didn't assign it to a data set, it would just print out here in my console. But if I open that up, I like to always kind of store things. I'm kind of a pack rat. I think when it comes to that in R, I like to always have, like, you know, reference to what tables I ran. And so you'll see here that now I have the totals. So basically there were over 10,000 people surveyed. About half of them tested positive. Under half of them tested negative. There were about, and don't like, so I made this data up, so it may not be completely logical, but there were about 15,000 people, or 1,500 people eligible for treatment. And then this number was treated. And then I calculated the proportion that was treated. So basically the number treated over the number that tested positive. And then the treatment uptake, which is the number treated over the number that were eligible. So you'll see that uptake is relatively low at 18%, but, or sorry, treatment proportion, the proportion treated is actually relatively low, but many of those people weren't actually even eligible for treatment. So treatment uptake is a little bit higher. So anyway, so that's something that we might want to look at. And then I think the real kind of usefulness of this comes in by using the group by command. So basically now I want to know, what about by career? So what were the totals by career for, you know, and this could be asking the question, you know, like, are farmers more likely to test positive than surgeons? So if I go ahead and run that, and again, so I'm just running it by, I place my cursor anywhere within the command, and I do, I'm on a Windows, a PC, so I just do Control Enter. So when you do Control Enter, it will run the command. And so now you see, if I open up this career table, now it has the results broken out by astronaut, farmer, pilot, or surgeon. So now I know, you know, the largest group surveyed was astronauts. Apparently there's a lot of them. And the second largest group was surgeons. The third largest was pilots. the largest group that tested positive was also astronauts. So basically, if you're looking for differences between the different career types or by groups, then that's how you would calculate it here. And then looking by age is always something that we want to do. Age is frequently an element that's associated with disease status. So you'll see here that it looks like the majority of individuals that were surveyed were in between the ages of like 20 to 39. And then the same for the test positivity. And so you might ask, you know, like, so were people in this age range more likely to be infected than individuals in older age groups? And it does kind of look like, I should have calculated, sorry, I should have done the actual treatment incidence, or sorry, the test positivity. So let's go ahead and add that actually. So say I wanted to know what proportion of people surveyed actually tested positive. And so that's really easy to add. Generally, I copy and paste all the time. So I'm just copying the command that was put here previously. I want to know, oh, sorry, this is not where I want to do it. I actually want to do it because I'm doing a calculation with multiple variables. I want to do it down here in this mutate portion of the command. So I'm going to go ahead and add a new one called prevalence. And so this will be the number of people that test positive. So that will be the sum of those that test positive over the sum of the people that were surveyed. And so if I run that, you'll see that now, oh, sorry, wrong one, career, oh, age, sorry. Now you'll see we've added a column that has the prevalence of the disease by each age group. So you can see it's actually relatively consistent from younger to older. It looks like maybe this age group, whatever this is, 30 to 34 and 40 to 49 have the highest prevalence, but it's actually pretty consistent across age groups. So anyway, so that's what I would look at. And then finally, also another thing I'll use frequently, if I get data out and it's in, it's delineated by periods. So for example, the period here is monthly, but what I really want to ask is or maybe CDC is like, I want quarterly data, not monthly. So what I'll do is I'll just compute a new variable using my mutate and my if else code. And again, that resource that I posted in the last slide, in the slide resources, is really great for this. So basically I have, if any of these names are, or if any of these text strings are within the period name, then assign it to Q1, else assigned to Q2, Q3, and so on. And if there's none of these match, assigned to NA. So if I go ahead and do that, whoops, that's not what I want, sorry. It only ran the if else. So if I go ahead and run that, you'll see now that if I look at my aggregate data, I have added a variable called quarter, and for whatever reason, it didn't work. It might not have worked because I ran that other thing beforehand. Hold on one sec, let's try it again. Still didn't work, not quite sure why. Anyway, I'll go back and debug that and figure out why it's not working. And if anyone figures it out, let me know. It might just be the way that it's formatted here. So anyway, then I can look at trend over quarter. So if I actually wanted to group it by quarter, I could look at that. And then, oh, sorry, I did skip this one. So basically the other thing I wanted to mention is that you can group by multiple variables, which is super interesting. Super easy, very, very helpful. So here I wanted to group by both career and age. So if I go ahead and run this code, then the output that I get out, so the career age table now has 32 observations, but now I have 4 astronauts that are 15 to 19 years old. What are their statistics? 4 farmers that are 15. So now I've broken out the results by both career and age. And so this is really helpful because these disaggregations of the data will be, we typically have to report these to CDC or to, the public health agencies. And it's very helpful to be able to run these. So basically, I think using this approach and using this aggregate function is very helpful to I think if you thought about how you would do this in Excel, what you would do is kind of use your filter or, filter and then count manually. You wouldn't be saving it all of your steps like you are here. You would maybe be prone to kind of errors that are introduced by doing things manually. So really, this is just a much better option and super quick and easy. And once you have this data or this code saved, you can use it for many other data sets as well, which is generally what I do. When I'm writing code, I go back to previous code that I've used before and just copy and paste all the time. All right, so since we're already at 20 after, let me go on to the next, the pre-post analysis. This one is actually a little bit longer, so I'm not sure we'll have time completely, but again, I'll kind of try and walk through it quickly. I'm just gonna go ahead and clean my environment just so that I have cleaned up. So remember, this was a pre-post assessment, which means that we administered a questionnaire prior to and then following an intervention. So here I've used a few more packages. They're all, I think they're all loaded already. But again, I'm just using, I actually used read CSV here for my pre-post. And you'll see there's 66 observations and 22 variables. We have the ID. I had previously computed whether or not they had answered all the questions. And so you'll see here, so these are I shortened it to only 5 questions, but so basically these 5 columns are the result of the 5 questions that were administered prior to the intervention. And you can see here that they're coded a little bit funny because they're multiple choice. So they were A, B, C, D. And so this person chose D, which was levofloxacin. This person chose B, which was linezolid. So basically, it doesn't really matter. We don't need to know kind of the responses, but we do need to know which one is the correct response, right? So what's the correct answer here? So we have all these questions here. The only other thing we have here is in the post questionnaire, they collected gender. And then the post questionnaire has the same 5 questions, but you'll notice here there's lots of missing data. And so that basically means that this row of person, she or he did the pre-questionnaire, but not the post questionnaire. So we're unable to actually compare the pre to the post. So anyway, so that's what the data set looks like. And so this data set was actually collected using a survey technology called Qualtrics. And that's where I pulled those screenshots from as well. So basically, Qualtrics is just an online tool that you can use to create surveys. And then you can download the data as a CSV. And so this is what the CSV would look like. The columns actually, I cleaned them up a little bit. They would look much different, but it will give you the actual data. So I go ahead and read that in, I clean the names. And then what I wanted to do was, because these names were so long and I really don't care. And actually in the original questionnaire, some of these were full sentences. But I actually really don't care that all I really want to know is that they answered D. I don't really care that this whole big long levofloxacin. So what I did was I actually just reduced I recoded them so that they only had the multiple choice question. So A, B, C, or D. And so I did that using applying a function a substring function where you're extracting just the first character in that variable. And I'm applying it to columns 8 through 12. And so if I do that, you'll see, so I did it just for columns 8 through 12. And now if I open up my pre-post, you'll see here, now they're cleaned up. Like basically now it just says D instead of D parentheses, blah, blah. So this actually just makes it much easier for me to like analyze the data moving forward, because now it's just kind of a simple one character reference. So I can do it also for the post. So now I have both the pre and the post. So this is the pre-questionnaire and this is the post. And then this was like kind of the big thing that I did here, which was, I think, much easier than doing it in Excel, which would be, I want to know, like, they answered A, B, C, or D, but like, which one was the right answer? And how do I know if it was the right answer? So I asked my colleague, you know, to give me a list of all the correct answers. And then what I did was I recoded them in another variable. So I retained their original answers, but I recoded them in another variable to say, like, so the correct answer for question 1 is B. So basically, if someone answered B, then I assigned them a score of 1. If they answered anything other than B, I assigned them a score of 0. So if I go ahead and run that, you can see that now when I go to, I've added another variable here at the end where instead of listing A, B, C, D, it lists basically incorrect or correct, where 0 equals incorrect and 1 equals correct. And I'm sure, I feel like there is probably a way to do this. So because you could try and do like a apply statement, or I'm sure there's probably a function to write about this. So I can also look at the result here. So you'll see here, this was the original result. So basically 8 people said A, 41 people said B, and 17 said D. And then when I recode it, I normally do that just to double check that I've coded things correctly. 41 got it correct, which aligns with 41 that had B. So I always like to check, at least for the first time I run something. And then I have to run it again for every question. So in the original, I actually ran it 15 times and created 15 different. And the reason why this was kind of confusing to me was because it wasn't like the same, there wasn't the same response every question, right? So the first question, the first correct answer was B, but the next one was C and the next one was D. So there wasn't really an iterative way that I could code it where I wouldn't have to write it out every time, but I'm sure there probably is a way. I think maybe what you could do is create like a, like an index or like a vector where you put all of the correct answers into a string and then apply that. But anyway, so there's more complicated ways to do it, I'm sure, but this is just the way that was easiest for me at the time. Certainly if I had a questionnaire that was like 100 questions, I'd want to try and figure out how to do it iteratively rather than writing it out every time. And that's definitely an option. So anyway, so I'm going to run all this just to get all the correct answers. And then what I want to do is actually calculate the total score of the correct answers. So for here, I want to do how many people, or what was the score of the pre-test and what was the score of the post-test. And so basically I use row sums. I use this a lot as well, this function. And I'm summing question 1 through question 5 of the pre-test. And I'm creating a new variable called pre-sum. And so if I run that, and then I also sum the post-test, you'll see that now I have pre-post assess. And at the end, you can see now I've added 2 variables where I have the pre-sum. So this person scored a 4 out of 5 and didn't complete the post. This person scored a 2 out of 5 and then scored a 4 out of 5. So they increased their score significantly. But what I would want to do then, I have both scores, which are useful to know, but now I want to know what's the difference between those 2 scores. So like, how did the score change over time? So now I'm going to just use standard mutate just to do subtract the pre-sum from the post-sum to get the difference between the two scores. So I run that, and now you can see that now you have the scores. So some people actually got worse after the intervention. Some people got better. Yeah, so now you can see like kind of the range of scores over the course of time. And again, this is made up data, so I don't even really remember if, I don't know if it makes sense logically, but, and then I want to analyze my data kind of in two separate groups, right? Like I want to know what was the scores or what were the characteristics of people who completed both the pre and the post questionnaire, and then what were the scores of the people who just completed the first one. So those are kind of two different groups. So what I want to do is create another data set where I'm filtering by whether or not they actually completed the survey, both surveys. So here I'm just saying, you know, filter this pre-post assessment data set if both complete equals 1. I have a variable in there that says if it equals 1, that means they completed both the pre and the post questionnaire. So now I run that and I can see that there are 42 people that completed both the pre and the post questionnaire. And then I just want to do some like, you know, quick analyses like statistics on the results. So basically, what was the average score of the pre-test? What was the average score of the post-test? And then what was the average difference? So if I run this, you can see that average score of the pre-test was 2.9. The average score of the post-test was 3.2. So it increased. So that's good. So that means potentially that there was a difference. And then if you do the difference, the average difference between pre and post was pretty small, just 0.23. And then you can also do median. So if you think that maybe your continuous measure is skewed, we generally, and also it's less reliable, it's less impacted by skewness in general. So it's a good default looking at median and interquartile range. So the median for pre is 3 and the median for post is 4. Batul, go ahead and ask a couple questions. I'm happy to.
Yeah, we've got a couple of questions, most of them related to the like why you prefer this tool over this or best practices. So yeah, one of them is asking, did you consider using the Dplyr case win instead of using FLs multiple times? What's your review on that?
Yeah, that's a good question. I actually, did I do that here? No. I don't know. I kind of go back and forth. But you're right. Like I could have used case when, and I do use it sometimes as well. But I just didn't do it here. I don't know why.
A second question, just asking similar question about good practice. So when you use Dplyr and a group after doing all the calculation to prevent like unexpected error and later analysis, he given like some, I think, a link from Bookdown about how we cannot. What's your review on this? Did you try it? Do you find that easier? Yeah.
Sorry, Batul, you were breaking up a little bit. Could you just repeat the like last part?
Okay, sorry. So some blogs mentioned that's a good practice to use any group from Dplyr after doing calculation using group by to prevent unexpected error in later analysis. For example, we cannot group or remove columns that are grouped together. What's your review on this?
Yeah, I think that sounds, so did you say that there was like a reference provided?
Yeah, from Bookdown. So I can just copy and paste that in the chat so you can see it as well. Yeah, here you go. I think
people we cannot drop
just about.
Yeah, no, I haven't actually heard about this, but I'll definitely take a look. Yeah, I think possibly because I'm doing, like I'm producing separate tables for each one of my groups. I think if I was going on to then do analysis on that output table, then I think that this would be probably more relevant, which is probably very warranted. But because like basically my endpoint is just that summary table, I think I probably don't have to ungroup afterward.
Yeah, it makes sense. Absolutely. Yeah. Those are the two questions that we have. And actually, I think we are just, in time, like it's now. So I really, thank you not only for being given this very, very informative workshop, but also very, very entertaining. I can't thank you enough for taking your time to prepare the materials. And I think also the participant beyond inspired by your journey. So thank you also everyone for attending, asking questions. Don't forget that there is an upcoming workshop for introduction to how to use Git in RStudio. There's also introduction to R-Shiny. Thank you guys. And thank you so much, Brianna.
Yeah, thank you so much, Bajol. Thank you for having me. Simi, do you have anything you want to mention?
No, not really. I just want to acknowledge R-Ladies Bergen. I think they're here, as well as R-Ladies Abuja. Thanks, girls, for joining us. And thank you so much, Brianna. I liked the talk. If you're willing, we could do a part 2, if you don't mind. And thank you so much, Batul, for facilitating. I think this was the best facilitating I've ever seen.
It was awful. Thank you for saying that. Thank you, Semi. I mean, she did all the work. Thank you, guys.
No, not at all.
If anyone has questions, you know, the code is shared on the GitHub. So please feel free to take a crack at it and just let me know what you think. And if you have feedback or suggestions, I'm also happy to hear those as well. So thank you.